Solving linear equations beyond the basics 1. A linear equation is an equation whose highest power of a variable is 1 when simplified. And I added the when simplified because there you could have other things going on there. But anyway, in addition, there are no variables in the denominator or the bottom. So you can have a fraction. It just needs to have a number in the bottom or denominator, not a variable. In Beyond the Basics 1, we will focus on linear equations with multiple terms on one side or multiple terms on both sides, and will require multiple steps. All right? So when solving linear equations, these steps always help you solve. Simplify both sides of the equation if necessary. Okay? It may already be simplified. If it is, that's fine. But if you need to, simplify both sides. Move all the variables to one side and all the numbers or constants to the other if necessary. If that's already done for you, you don't have to. All right? So when I use the word numbers here, I'm referring to constants or numbers that are not attached to a variable as a coefficient, okay? This video will focus on multiple step solutions. For more information on the basics, watch my video, Solving Linear Equations, the Basics. So here, 2x plus 5 equals 13. So we sort of ended the basics video right here in this same realm. All right, so let's do these and then check these two on this page. So 2x plus 5 equals 13. When I look at this, I have two terms over here and one term over here. When that's the case, can I simplify either side? No, it's already simplified. So then what's by itself? The 13. When I have more than one term, I probably need to move something off that side. So what can I do unless they are like terms and they're not here? So I need to move the thing like the 13. Move the plus 5. How do I move the plus 5? I subtract it from both sides. Subtract it from both sides. Right? Again, I have students, Mr. Guess my teacher just said write a minus 5 on the other side. But where does it come from? I don't know. That's just what they said do. No. This is why. One of the oldest axioms in math here. If you subtract 5 from one side, subtract 5 from the other. Okay? We're going to show what we're doing here. I always show these steps. I want to drive the point home. Once you get familiar with this and you can do this in your sleep, hanging upside down from the ceiling, then you can skip steps. But here, show your steps every time. If you're trying to learn algebra, you wouldn't be watching this video. You're not just watching it for fun. All right, 2x equals, that cancels the plus 5 minus 5. 13 minus 5 is 8. So we have 2x equals 8, but we're not done because we don't want 2x, we want x. So how do I undo the 2 times the x? I divide both sides by 2. So x equals 8 divided by 2 is 4. X equals 4. That's my final answer. And then if I want to check it, I come over here and I go back to my original equation. 2 times something plus 5 equals 13. So if you haven't seen my videos, I always plug something in inside parentheses. Here, you have to have the dot or put parentheses because you're multiplying it by the 2. We don't use an x for times in algebra, so if you're in that habit, stop. X is a variable now. Don't use it for times. All right? So then 2, and then we're going to plug in x is 4 right here. We're going to plug it in for that. So we're going to say 2 times 4. So then 2 times 4 is 8 because we're going to multiply before we add. 8 plus 5 equals 13. We're bringing down the plus 5 equals 13. We're going to add the 8 plus 5. That's 13 equals 13. Guess what? Checks out. Boom. It's good. I didn't have my little divider line here, but here's another problem here. Negative 2y minus 5 equals 7. We're going to check it again. Again, I put the check in here because many books, many teachers want you to do that. If I ask you to check in my class, I want you to show me the steps like I just showed you over here on this side where we checked it. I want you to check it and show me these steps. Don't skip anything. I need to see it. No, I just checked it in my head. No, you didn't. You got the same answer because you just worked it. You're going to tell me you checked it. No, I need to see it. And so you just make sure with your teacher, your instructor, your professor, whatever, that you know exactly what it is they want. All right, if they say check it. And then you provide that because they're the teacher. Don't go, I don't agree with that. You're the student. It doesn't matter. Okay? You're in their class. Do what they say. All right? So then negative 2y minus, within reason. All right, negative 2y minus 5 equals 7. So then here, again, 2 terms equals 1 term. So what's by itself? The 7. Got to move the negative 5. How do I do that? I do that by adding 5 to both sides. That cancels over here. Negative 2y equals 7 plus 5 is 12. And then what? Need to divide both sides by negative 2. That divides out. That does not cancel. Right? I know that if you look it up in Merriam-Webster's dictionary online, it will say it cancels. That's because math teachers lied to the dictionary so long they just put it in there. Okay? So up until about 30 years ago, it was in all the math books. The only book in my office that says it now is over 30 years old. No book I have newer than 30 years old says the word cancel for that in anywhere that I can find. Okay? And I've searched for it. Okay? So there may be books still out there that say it, and your teachers were taught that way, so give them a break if they still say the word cancel. And you were probably taught it cancels, but it doesn't. All right? So then that divides out. Y equals, and then a positive divided by negative is negative. 12 over 2 is 6. So Y equals negative 6. And again, we want to check this. So I'm going to go back to my original. Always checking the original equation. Don't go down there and say, oh, well, let me check it here. No, always the original. Negative 2 times Y, that's Y, right? Minus 5 equals 7. So here we're checking it. So then if we plug Y in, well, what do we get for Y? Negative 6, right? Plug it in there. So then remember, we multiply this together before we add or subtract anything. So negative 2 times negative 6. That's positive 12 minus 5 equals 7. Then we put together 12 minus 5. We get 7 equals 7. And boom, it checks out. There it is. Boom. Works. So let's look at the next one. 6x minus 3 equals 63. Again, two terms is one term. What's by itself? The 63. So what do I move? I move the minus 3. How do I move that? Add it to both sides. 6x equals, what is 63 plus 3? 66. And then what do I do? I need to get rid of the 6 times the x. I do that by dividing both sides. The 6's divide out. They don't cancel. They divide out. That becomes x because they become 1, right? That's 1x. It's not 0x. Things cancel when they go to 0. All right? And then 66 over 6 is what? 11. Got something on my screen here. All right. Forgive me. I was trying to clean something off my screen. X equals 11. 5x minus 30 equals 7x is the next one. So here we have two terms equals one term. So always move things to the one term side. It's the shorter way to do this. Okay? I mean, there's one time when it's the same number of steps, but it's usually shorter. So then here, I'm going to move this over because I have x's over here. That's how I know to move the 5x. I always look at the thing by itself when there's multiple terms on one side and say, okay, I want to simplify both sides. It's already done on all these so far. Move the 5x over. So how do I do that? Subtract 5x from both sides because it was positive. I know it was the first term, but this minus goes with the 30, y'all. Don't make that part of the 5x. It's not part of the 5x. So then this cancels and we're left with negative 30. Don't forget that negative's there. 7x minus 5x is a positive 2x. The signs are different. Subtract and keep the sign a little larger. I know you say, well, Mr. I've been doing 7 minus 5 since first grade. I know. What about 5 minus 7? It's negative, right? So here this is positive 2x, and then what do? We divide by the 2. So then that divides out. We're left with x on the right-hand side. Left-hand side, negative. Positive is negative, and 30 over 2. What is half? X equals negative 15. And if your teacher requires the x on the left, you just write it on the left. Just turn that around. If negative 15 equals x, then x equals negative 15. That's one of the oldest axioms or whatever rules in math. If a equals b, then b equals a. Doesn't matter what order it's in. But again, if you're in somebody's class and they require that, do what they require because they're the one grading your papers. Hello. It'd be insane not to. 3r plus 5 equals 2r plus 13. And then we'll check this one. So look, notice my original equation has 2 r's in it. It means I got to plug in my answer twice. So look, here's what I tell my students. I'm going to tell you this. When you have a scenario like this, both sides are simplified and both sides have a variable and a number. So both sides have r and both sides have a number, a constant. It doesn't matter. You can move the 3r by subtracting it from both sides. You can move the 5 by subtracting it from both sides, the 2r or the 13. There's 4 things you could do here. So there's several different ways you can solve this. The hint that I give my students is it doesn't matter what you move unless the variables are one different. In this case, 3r and 2r. What's the difference between 3 and 2? 1. And don't think it's 1 if it was 3 and negative 2. That's not 1 apart. But if they're both positive or both negative and they're 1 apart, move the smaller one. Which one's smaller? 2r. So I'm going to subtract 2r. And I want you to get to the point. Look, I want you to get to the point where you say, hey, I canceled this. Let's subtract 5 from both sides. I want you to get to that point. But right now we're just going to do one thing at a time. So if the r's or the variables are 1 apart, move the smaller one. If they're not 1 apart, move anything you want to move. But if they're one apart, moving the smaller one saves you one step. And what I believe, this is me, different people believe different things, but me as a math teacher, what I believe, because look, let's face it, if you're in here trying to learn this, you're trying to get through a class, and quite frankly, some of you are trying to get through college algebra, when you finish it, you're done. Until you have a ninth grader who's in Algebra 1 at school and you're trying to help them, right? And then 20 years ago, you're like, I don't know how I do that. Okay? So, look, the biggest thing you will take with you in your life from math is efficiency and problem-solving skills, okay? Being efficient, problem-solving, right? Thinking from problem to solution. So here, this is efficiency. I need to recognize that my variables are one different. 3R, 2R, move the smaller one. It will save me a step. If you can take that to your job and save a step, what if you do something 300 times a day and you save one step 300 times? You are more efficient than me if I'm doing that one step 300 times, right? So when the promotion time comes and your boss says, hey, by the way, you do 500 and guest over here does 200. I'm promoting you, unless, right, my dad owns the place or something, right? Then I'm probably getting the promotion. But outside of that, boom, you're more efficient. You want to be efficient in life, in all aspects of life, okay? So 3R minus 2R is just good old 1R. Remember, we don't put the 1 there. It's 1R means R. Just put R. R and then bring down your plus 5 equals what? 13. And now, what do I need to do? The 13's by itself. Move the 5 by subtracting it from both sides. So then R equals 13 minus 5 is 8. R equals 8. Now we're going to check it. So we're going to come over here and say 3 times, that's R, right? Plus 5 equals 2 times, there's R again, plus 13. Okay? So what is my R? I'm going to plug this 8 into both those places now. So put an 8 here and an 8 here. So then here, multiply. 3 times 8 is 24 plus 5 equals. I'm not even going to go to that side yet. Let's finish simplifying this side. Put those together. 24 plus 5 is 29. Now let's go to the other side. 2 times 8 is what? 16, and then plus 13. And what is 16 plus 13? 29. Check. Boom. There it is. It worked out. Beautiful. Beautiful. 29 equals 29. Checks out. Boom. Always go to the original. Don't move things from one side to the other when you're checking. Simplify one side, simplify the other side, and if they ain't the same, you either messed up checking or you messed up solving. Okay? Go back and make sure you didn't miss a step, subtract both sides when you should have added, or, divide when you should have multiplied, or something like that. All right? So, always a good idea to check, even if your teacher doesn't say check, even if you run a mental check. But if they say check, they probably want you to do what I'm doing and show all the steps where you plug it back in, so they can see that you understand how to check it and what you're doing there. All right? So here, if I look at this, 20 minus 7m equals 26 minus 8m. Again, both sides are simplified. So what do you want to move? I can move any of them. You say, wait a minute, Mr. Guest, you just told me if they're one apart. -7 and -8 are one apart. So which one's smaller? -8, right? The negative numbers further to the left is -8. So we're going to do what? We're going to add 8 to both sides. We're going to add 8, not add 8, add what? Because I jump all over my students when they say add 8 to both sides, and I just stand there and say, I don't even know what you're talking about. Add 8m to both sides, right? That's not an 8, that's an 8m. It's a -8m that we're changing the sign to a positive, so plus 8m because we're undoing it. We're adding it to both sides so it cancels on the right. So if I do that, that's going to be 20, bring that 20 down, minus 7m plus 8m is plus m. If they're one apart and you move the smaller one, you always end up with regular old m or regular old x or regular old p or w or whatever. That's why it saves you a step. You don't have to divide by a coefficient. You can move something else if you want to, but this is the most efficient way to solve this. 20 plus m equals 26. And you learn to look at something from the beginning and think about the solution before you start. We especially in America, we live in this instant society where we just want to go, just do this. And we waste so much time spinning our wheels when if we'd have just thought about what we were about to do just for 3 seconds, we could have done it so much faster and more efficient. Okay? Many times. So now, what's by itself? 26, move the 20. The 20 is positive, not because of this plus, that goes with the m. but the 20 is positive because there's an understood plus in front of it. So how do I undo that? I subtract 20 from both sides. That cancels, and I'm left with m equals 26 minus 20 is good old 6. So m equals 6. So again, those m's were 1 apart. Move the smaller one. I did the negative on purpose to show you, hey, the negative 8 is smaller than negative 7 by 1. So 6x minus 15 equals 2x plus 13. Again, both sides simplify. Both sides have variables and numbers. Are they 1 apart? I mean the x's. No, 6 and 2 are not 1 apart, so it doesn't matter. You pick your favorite term here to move, and you can move the 13. You can add 15 to both sides. You can move the 2x, right? So in my class, I say, what do you want to move? And if they say 15, I go, whoa, there's no 15 up here. They're like, yeah, it is. I'm like, no, there's not. And I make them tell me it's the negative 15 because the negative goes with the 15 there. So I'm going to move the 2x. How do I move the 2x? Subtract it from both sides. That cancels over there, and I'm left with 4x minus 15 equals 13. Now, the best move, see, any of the 4 moves is okay there. Now there's a best move. The best move now is to add 15 to both sides because the 13 is by itself, and the thing like it is the negative 15. So add 15 to both sides. That cancels, and 4x equals what? 13 plus 15 is 28. And then what do? We subtract. We divide both sides by 4, and we get x equals 7. Okay? X equals 7. And that is our final answer there. X equals 7. So let's see what the next page holds for us. 4x plus 8x minus 2x, wow, equals 20 minus 15. So this is the first one we've seen, I think, where it's not simplified already. So let's simplify it. Well, over here, I'm going to simplify one side at a time, y'all. I'm not all this bouncing around. When I started teaching, I went one side to the other side, and I realized how confusing it was for students. And it may be confusing to do it this way just because that's probably what your teacher does. But I like to simplify the left-hand side all the way down and then go to the right-hand side and simplify it. And if I take 5 steps on one side and 1 on the other, I just bring it down to match it up. Okay? So here, put these first 2 terms together because they're like terms. 4x and 8x is 12x. When you add or subtract, when you combine like terms, and I mean add or subtract, you get a like term. You'll hear me say that a bunch, meaning if I put x's together, I get x. I don't get x squared or x cubed or y's, I get x. So 4x and 8x is 12x, and then bring down my minus 2x equals. I'm not worried about the other side right now. Now, do I still have like terms? So put those together. What is 12x minus 2x? Again, you still have an x. 12 minus 2 is 10. So 10x equals, now I go to the other side. I've already got that side simplified. There's nothing else I can do to 10x. Boom, I'm done, 10x. The other side, also like terms, not the same as x's, but they're like. 20 minus 15 is 5. Well, I only took 1 step, just bring it down. If I had a bunch of steps down here, I would just draw an arrow and bring my 5 down. Okay? Or if your teacher makes you write it down every time, do what your teacher says because you're in their class. Okay? But if you did, just write down 5 a bunch of times if it took, 8 steps on the left. 10x equals 5, and then what do? Divide both sides by 10. Divide both sides by 10. So that divides out x equals, what goes into both 5 and 10? Well, 5 goes into 5 once and 10 twice. So x equals 1/2. And that is my final answer. X equals 1/2. And then here, 3x plus 2 minus x equals 6 plus 3x minus 8. Again, if we look at this, we need to simplify at least one side, and in this case, both. So what can I do just on the left? See, I'm going to not worry about any of this right here. Just on the other side. What do I need to do to simplify this side over here? Do I have like terms? 3x minus x. And notice I underline the minus with the x because that minus sign goes with the x. It does not go with the 2. So then what is 3x minus x? Well, this is, remember, minus 1. We don't write it, but just remember it's there. 3 minus 1 is 2. So that's 2x plus 2 equals. Can I do anything else to the left-hand side? No, not as far as simplification goes. Simplify means remove parentheses, combine like terms. Some of you want to factor a 2 out. You might be remembering that. That's not simplifying something. Okay? Simplify, remove parentheses, combine like terms. 2x plus 2 equals, on the other side, I have like terms, 6 and negative 8. What is 6 minus 8? Well, they're different signs. Subtract them, get a 2, and the sign of the bigger is negative, and then bring down my plus 3x. So now, can I do anything else to that right-hand side? Nope. Don't have like terms, can't do anything with it. Now, are my two x's 1 apart? I have a 2x and a 3x. They sure are. So I'm going to move the smaller one, which is what? 2x. I'm going to subtract 2x from both sides. Doesn't matter. You could have subtracted 2, added 2, or subtracted 3x. Any of the 4 terms. But the best move here, because they're 1 apart, is to move this one. So that's going to give me 2 equals negative 2, and then plus 3x minus 2x is plus 1x. And then now this is by itself, so move this back over here with it. That's going to be what? Add 2 to both sides. So then 4 equals x. 4, it's the same thing as x equals 4 if you turn it around. So then 4 equals x there. And that's our final answer. So this was our first Beyond the Basics video. There are others. If you need to see other things about solving these that are more complicated, just go through there, and I have, they're labeled 1, 2, 3, 4, 5, or how many ever I have. Okay. So and then things that are simpler are the basics, and then all the Beyond the Basics are labeled that way.